Hello, I'm Hyuckjin Jang from KAIST, and today I'll be presenting our research on effective VR intervention to reduce implicit bias toward the people with physical disabilities. So let me start with a question. So when you see a wheelchair, what's your first thought? Is it positive or negative? So almost everyone possesses two kinds of bias, explicit and implicit. Where explicit bias indicates consciously presented bias toward a specific target, implicit bias is more like an unconscious attitude formed by past experience that even the person themselves may not realize. Several attempts have been made to address implicit bias through the real experience based on the Proteus effect theory, where the characteristics of the virtual avatar influence users' real-world attitude and behavior. While these studies consistently report that the people's implicit bias reduced after they experienced wheelchair using Avatar, but they faced a significant limitation that their different focuses on the bias types made it difficult to establish clear causal relationships. Also, we found an interesting pattern from the previous studies that the participants' implicit bias either decreased or, in some cases, was rather strengthened depending on the situational context they assumed. This opposite trend indicates that the situational context of the VR experience plays a crucial role in determining the direction of the bias change. And avatar embodiment is another essential element for effective perspective taking, typically achieved through the visual tactile or visual motor synchrony between the user and the avatar. However, wheelchair using avatars present a unique challenge. Limited lower body movement may hinder users' embodiment and distract the perspective taking. And another critical aspect of the avatar interaction is that male and female users have different perspectives on body image. While men tend to have a holistic view, women perceive their body as a collection of units. This raises a question about how these gender-based differences affect users' experience with the wheelchair avatars. And finally, we cannot overlook the impact of a pre-existing bias as well. According to the affective cognitive consistency theory, people tend to maintain consistency between their emotional evaluations and attitudes. Therefore, we need to examine how people's pre-existing biases affect the VR wheelchair experience. And based on these considerations, we developed several hypotheses. First, we aim to verify whether implicit and explicit bias show different patterns after VR exposure. And second, we investigate how varied situational contexts of the VR affect implicit bias. And next, we examine the impact of full body avatar visualization on implicit bias and potential gender differences as well. And finally, we explored whether pre-existing bias levels moderate the effectiveness of VR intervention. To test this hypothesis, we designed our study around two key factors. First, situational context and avatar visualization for VR experience design components, and the gender and pre-existing bias for individual characteristics. Participants were assigned either a gender-matched full-body avatar or an invisible avatar. The wheelchair-based interaction was implemented based on the previous study. Participants' real wheelchair movements were mapped to their avatar's actions, and all participants were given a 3-minute embodiment phase to familiarize themselves with their avatars and the wheelchair interface. The main task involved navigation of virtual building to locate 3 blue boxes. The first and second floors were connected by a gentle slope, while the second and third floors were accessible by elevator or the stairs. We manipulated task success using the situational variation. In the neutral condition, participants could easily reach the third floor using the elevator, but in the negative condition, we deliberately blocked the elevator, so making it impossible to reach the destination. For the measurement, the explicit bias was measured using the scale of attitude toward the disabled persons, with the higher score indicating more favorable attitudes. And for measuring the implicit bias, we implemented the disability attitude implicit association test. This task involves rapidly categorizing images related to the physically able or the disabled, and words with the good or bad semantic meanings. So block 5 paired the physically abled image with the good words and the physically disabled with the bad. And then in the block 3, these pairings were reversed. The reaction time differences between these block 3 and 5 indicate the implicit bias levels, and more positive value means the more favorable attitudes. And in the experiment, we recruited 88 participants, and we balanced the number of participants based on the gender. And again, we grouped them based on their pre-IAT scores, so high versus low pre-existing bias level. The experiment was conducted in 2 sessions. In the first sessions, we measured the participants' baseline bias levels. Then 3 to 20 days later, the participants returned for the VR experience and the post-bias measurement. To quantify the changes in implicit bias, we calculated the delta IAT scores by subtracting pre-IAT scores from the post-IAT. And likewise, changes in explicit bias were measured using delta SADP scores. Also, a post-VR survey was conducted to ask participants' perceived avatar embodiment and the task load. So now, let me explain our findings according to our hypothesis. So each analysis was conducted using the following methods. First, the implicit and explicit bias showed the different patterns after the VR disability simulation. While explicit bias significantly decreased, implicit bias remained relatively unchanged. This suggests that participants may have consciously presented more unbiased attitudes due to the social norms and expectations. And interestingly, while pre and post measurements show no correlation between implicit and explicit bias, their change score, delta IAT and delta SADP, showed a positive correlation. This indicates that while these biases are independent, they change in consistent direction and magnitude. The larger the implicit bias change, the greater the explicit bias change, and vice versa. And second, the situational context showed no significant effect on implicit bias. For the delta IAT score, there were neither a main effect nor an interaction effect of situational context with the avatar visualization. The NASA TLX results confirmed our manipulation's validity, as participants reported the higher task load in the negative conditions. However, the physical demand and effort subscales showed no group differences, suggesting that the inherent physical fatigue from the wheelchair interaction may have offset this effect. And next, participants experiencing a full body avatar showed a higher implicit bias, but these effects varied by the gender. The avatar visualization showed an interaction effect with the gender. In detail, male participants with the invisible avatars showed a decreased implicit bias, while those with the visible avatars showed an increased bias after experiencing the VR. Then why did this difference only occur in the male group? So as you can see, the gender had a significant interaction effect with the situational context on the avatar embodiment level, where the only males showed a lower embodiment in the negative conditions. And previous research suggests that the Proteus effects can sometimes lead to negative consequences when avatar appearance is perceived as less attractive or invokes some stereotypes. Given men's holistic body perception, they may have responded more negatively to lower body asynchrony. And in this perspective, the invisible avatar may have allowed males to distance themselves from their appearance-based influences and resulting in decreased bias level. And finally, the effectiveness of the VR intervention varied based on the pre-existing bias level. Participants with the higher initial bias showed a greater reduction in both implicit and explicit bias, while those with the lower initial bias showed a less improvement or the slight increases. While these results contrast with the affective cognitive consistency theory, it partially aligns with the Walworth suggestion that the perspective taking may have less impact on people with lower bias levels, possibly due to the greater room for the improvement in those with the higher pre-existing bias. So taken together, our study provides comprehensive insights into how VR experience design and individual characteristics affect people's bias reduction, and suggests guidelines for developing effective VR interventions. In future work, if we extend our research scope to the social context and examine a broader range of individual characteristics, we will be able to strengthen our findings and induce more effective VR-based perspective taking on the people with physical disabilities. So thank you for your interest in our research, and thank you.